Chapter 19, Trinity. It was a warm morning that July 16th, 1945, in the desert of New Mexico, some 120 miles south of Santa Fe. The blast had been scheduled for dawn, but a sudden passing storm had delayed the experiment for hours, and it was only as 5 o'clock neared that the go-ahead was given. The test had taken many months to set up. Early that morning, those who had been involved in it, the dozens of scientists, engineers, and military and government officials, as well as individuals who had been invited to view it, had left their homes and hotels while it was still dark and had driven to the test site. They had watched the dark sky, anticipating how it would soon light up as if it were morning. The test had required a good-sized piece of wide and flat land, as they knew this would give them better fallout measurements after the explosion. They had also wanted the test site to be a good distance from the populated area of Los Alamos, away from curious eyes. The distance served another purpose. Following the explosion, the fallout on the inhabitants would not be too dangerous. President Truman had known about the test from the start and, along with the rest, had agreed with General Groves to pick an area where no Native Americans were residing so that they would not be displaced from their homes. The area had been a practice bombing and air-to-air gunnery range for B-29 and B-17 planes, so the nearby population was accustomed to hearing odd explosions. In the middle of the large expanse of land, a 100-foot steel tower had been erected, above which the bomb itself was secured. Scientists had developed several ways in which the bomb could have been constructed, measuring, calculating, scrawling various possibilities on paper and blackboards, and finally settled on an aerial burst as the option likely to give them the most effective results. Some 200 people knew of the classified operation, but only a few had been given permission to attend. Those few could not help themselves. They stared up at the bomb in astonishment, as it dawned on them that what had been only a possibility up until this point was now a tangible reality. They could hike up and touch its cool metal if they had been allowed to, although only J. Robert Oppenheimer did that. They could sense its weight. It was a real thing. With the flick of a switch, with a slow countdown, the bomb would go off and they would blast into the unknown. It was a frightening yet very exciting thought. They would admit later on, even if only to those who persisted in asking. Several of the scientists who had not been invited to watch the test had, regardless of regulations, crawled onto the nearby borderland, which was made up of more than a 30-mile radius, intent on being witness to history. Several scientists moved into the photo bunkers, the closest locations they could find to view the explosion. Now they found themselves ready to watch the first nuclear test explosion as it pierced the pre-dawn air. President Franklin Delano Roosevelt had died 3 months earlier on April 12th, and Vice President Harry S. Truman had taken his place, becoming the 33rd President of the United States. While serving as Vice President, Truman had not been aware of the Manhattan Project, though he had suspected that some kind of secret military operation was underway. But soon after taking office, he had been briefed on the rush to complete the atomic bomb, and he had agreed to go forward with the test. He knew what was happening in New Mexico, and he eagerly awaited word of the outcome. Up until 1942, the possibility of building a bomb had been just that, a possibility. Despite numerous discoveries and scientific advances, no one knew for certain if it could be done. But after December 2nd, 1942, when Fermi and the other scientists in his University of Chicago research group, beneath the stands of Stagfield Stadium, had successfully tested sustaining a chain reaction long enough to make a bomb, the possibility had become reality. The evening prior to the Trinity test in New Mexico, many of the people involved in it, including General Groves, were asked to stay near the bunkers at base camp, located some 10 miles away. Such a precaution was especially necessary for General Groves. He and Oppenheimer, the two men in charge of the entire operation, were not to be in the same place at the same time, so that in the event that something catastrophic happened, at least one of them would still be there to give orders. As this was the first test of a nuclear bomb, no one knew exactly what would happen. Nuclear fission had never been attempted at this scale, and some of the scientists, deep down, were afraid that the test would ignite the atmosphere and cause global destruction. While this was a very distant possibility, the extinction of the human race seemed to them to be a real option. But many others didn't believe that anything would happen at all, thinking that all their effort would go out in a flicker of nothingness. For days, every calculation had been done and redone, checked and rechecked. Every wire, knob, and pile had been secured and tied down. Weather reports had been looked at and adjustments made depending on cloud patterns and wind shifts. Yet the reality was that they were trying something new, and something could always go wrong. General Groves, the man in charge of the entire operation, had made plans for all imaginable eventualities, including evacuating nearby towns and implementing martial law if anything horrifying should occur. But he didn't want to think of that possibility. He was conscious of his image, of how he came across in the press and to his superiors. He worried about what others would say of him after the war, particularly if the bomb turned out to be a dud. Think of me standing before a U.S. Senate committee after the war when it asks me, "General Groves, why did you spend this million or that million of dollars?" he told Oppenheimer. But while he was concerned about his superiors, he didn't care all that much about the scientists. He didn't like them, nor was he bothered by what they thought of him. He always pushed them to do better and to finish on time, and he was aware that they liked him as much as he liked them. Many of the attendees began to feel chilly, and it was on the rain that they blamed their shivers, not on the nerves they were experiencing. They tried to behave normally, as if this were just another day, another experiment that they were performing in the comfort of their laboratories, but they all knew better, and it showed on their faces, in their twitchy movements, in the muttering of their lips, in the numerous packets of cigarettes they consumed, even though they had been warned not to smoke, given all the wiring snaking around them. Oppenheimer was pale and tense and could barely catch his breath. Those near him feared intruding on his thoughts, so they stayed some feet away and left him to his own devices. More than anybody else, he was aware of the dangers behind the bomb's science, what could happen if it didn't work, but also what would happen if it did. The pressure seemed to crush him. It was unlike anything he had ever felt before or would ever feel again. That sense of unease grew as the countdown started. He knew that the lives depended on the outcome of the test. At supper the night before the test, the attendees had been advised about what to do during the explosion to prevent eye damage, to prevent irradiation, to prevent ear damage, to prevent being knocked down to the ground. In essence, they were advised to wear goggles, not look directly toward the blast, if they could restrain themselves, to wear earplugs, although the sound would penetrate regardless, and to hold on to something, for even though they would be standing some distance from the blast, the ground beneath them was likely to tremble, and they might find themselves losing their balance. The blast would be the loudest, brightest thing they would ever see, they were told. They needed to take precautions, and now, with 0 hour approaching, they tried to remember what they had been told. As the time for the firing arrived, it was hard to imagine that all those weeks and months of preparation were finally coming to this. Looking up, all could see the bomb resting in its tower, appearing not particularly threatening. The surrounding area was becoming crowded, with everyone waiting to take their places when the signal was given. Rain came down heavily, and they even noticed some rumbles of thunder. Those in attendance wondered whether the test would go forward, and if it did, how the weather would influence the outcome. The 4 a.m. detonation had been canceled, and as they inched towards morning, the rain still came down with abandon. The lightning in particular was a big concern, as miles of wiring were attached to the bomb and sticking out from the now soaked ground. Any electrical surge could prove disastrous. But at 5:29 a.m., as the city lights flickered dimly in the distance, scientists flipped a switch for the detonation and held their collective breath. They heard a brilliantly loud burst, and in that moment, all their studies, all their expertise, all their research and theory became reality. The bomb worked flawlessly and produced an explosion brighter than anyone had thought possible. A huge cloud billowed upward, reaching an elevation of nearly 40,000 feet, the light visible almost 200 miles away. Val Fitch, a scientist who witnessed the blast, later said, "It took the blast wave about 30 seconds. There was the initial loud report, the sharp gust of wind, and then the long period of reverberation as the sound waves echoed off the nearby mountains and came back at us." Several scientists hopped into their trucks and for some time followed the radioactive clouds that trailed above them, some wondering where they would travel to, where the fallout would eventually land, and how far it would go. Some days later, they learned that it had rained in Illinois and that the rain had brought down small amounts of radioactive fallout. The clouds had traveled some 1,500 miles. Immediately after the blast, Fermi and Oppenheimer had calculated that the energy yield of the test was equivalent to about 20,000 tons of TNT. The witnesses no longer felt chilly. They sensed the heat coming toward them as the fireball grew and changed in color from yellow to orange to red, watching it climb upward towards the sky like a slithering snake. After a few minutes, it became dark again. But in the sky and over the surrounding area, there remained a purple glow few of them ever managed to forget. Those scientists who lived in the vicinity soon jumped into their jeeps and cars and returned home, where they quickly shed their clothing, headed into their showers, and scrubbed themselves with hot water and soap over and over again, as if the simple act of cleansing their bodies might help them rid of the radioactive material should they have been contaminated. Again and again they did so, later throwing the clothes they had been wearing into dumpsters. What had transpired in New Mexico was never supposed to happen. Although atomic science had been a subject pursued with excitement in Europe, the idea of an atomic bomb had seemed like an impossibility. According to scientific theories of the era, the atom was made up of a nucleus that contained positively charged particles named protons and neutrally charged neutrons. A good distance from the nucleus were electrons, or negatively charged particles, equal in number to the protons. The two never met. With the discovery of the structure of the atom, talk of harnessing the energy within it became a popular subject within the scientific community, particularly in the 1930s. For many, however, this had seemed more like science fiction than reality. Nonsense. Ernest Rutherford, one of the most famous physicists of all time, had been inspired to say. Nonsense. It was unimaginable. But here were the intrepid Americans in July of 1945 having successfully done the impossible. They had tested an atomic bomb. What had been debated and thought about for decades had taken them less than 4 years to achieve, proceeding from a somewhat abstract idea to an actual weapon, the likes of which no one had ever seen. The reality of it was staggering. The scientific community greeted the news with mixed reactions. There were those who foresaw what was to come, what in their minds meant the end of the war. However, there were also scientists who wished that the experiments had not come to fruition and that nuclear fission had remained science fiction, much as Rutherford had declared it to be. They also foresaw what was to come, but their view of the future was much darker and bleaker. General Groves was not one who debated the moral questions, nor did he believe that scientists should place their conscience above their work. He did not believe scientists had any right to question whether the bomb should be built at all, much less how it had to be used. Their job was simply to construct it and to test it. The military had the final say, and as General Groves told them, morality had no place in the military. They were fighting a war, and there was no time to ask all these philosophical questions. General Groves was thrilled with the outcome of the Trinity test, which he saw as his dress rehearsal. It was a major step forward, and he was now eager to move ahead with the real thing. But Oppenheimer, Groves' right-hand man, was suddenly overwhelmed with fear. What had they done? What would they do now? Famously, those who stood by him heard him whisper a notorious passage from Hindu scriptures. "Now I am become death, the destroyer of worlds."